For this lesson, we're going to be talking about multiplication properties of exponents. And so the warm-up is just what is an exponent, and we should all know what an exponent is, but whenever you have an exponent, you also have a base. So for example, something like 2 raised to the third power, the 3 would be my exponent, the 2 would be my base. And remember that 2 raised to the third power means I'm doing 2 times 2 times 2. It's 2 multiplied by itself 3 times. That's what an exponent is. Now we also need to talk about monomials. A monomial is a number variable or the product of a number and one or more variables with non-negative integer exponents. Okay? The main thing I want you to focus in this part is the non-negative integer exponents. So the exponent has to be a whole number. And it also has only one term. This is the other main point. It only has one term. So for example, if we look at this formula, this is kind of complicated. We could see that w times v over 234 raised to the third power is a monomial. Basically, the rule for monomials, besides that it has non-negative integer exponents, the part that means it only has one term, so monomials don't have addition or subtraction. And that's kind of like the third piece of it. So we know non-negative integer exponents, only one term, and no addition or subtraction within that term. Which makes sense because really if we think about it, in order for it to be one term, we can't be adding or subtracting anything. Alright, and then a special case, if it has division by a variable, it's not a monomial. I would just put a star beside that sentence. That doesn't come up terribly often, but it's good to know. And then we have a constant. We've talked about constants before. This says it's a monomial, that's a real number. Okay, basically constants have no variables. Then we have linear expressions. Linear expressions are when the exponent of x is 1. We've dealt with these before, and we know what their graphs looks like. And then we have nonlinear expressions. Nonlinear expressions are just whenever x is raised to something besides the first power. So if you have x raised to the second power, you have nonlinear. X raised to the first power is linear. I remember this because if it's raised to the first power, a 1 kind of looks like a straight line. So if it's raised to a straight line, it's going to be linear. So the first example, we want to look at whether monomials are existing or not. So we're going to determine whether each expression is a monomial, and then we're going to say why. So first one, 10, is this a monomial? Yes, because it only has one term. It's one term, no non-negative integer exponents, and we have no addition or subtraction. And since we just said you can't have addition or subtraction in order to be a monomial, we know that b is not a monomial because there is addition. F plus 24, we have 2 terms, f and 24. Since this 2 terms, it's not a monomial. It's not one term. C, h squared, that is a monomial because it's only one term and it's raised to a whole number. And then d, j is also a monomial because it's only one term. So in order to determine if something's a monomial, it just has to be one term and raised to a whole number for an exponent. And then remember the special case, you cannot be dividing by a variable.